Hey there, I'm José with Rely, and today I'm very excited to be doing a full product overview of Rely's intern developer portal that aims to automate DevOps for developers so that they can focus on the business instead of spending 3 hours a day or more on non-code producing tasks, as is backed up by the latest State of DevOps report from Google. Before going into the actual product demo, where I'm going to be walking you through the main capabilities and use case of the product, let me just briefly explain what an IDP is in the first place. So, a developer portal or an IDP provides a unified developer experience, unifying all of the different engineering workflows with Golden Paths. So, basically, standardizing and automating the key engineering workflows for developers to build, deploy, test, and operate software so that they can focus on the business. And it has got three main features or three main capabilities. The first one being the system of record or the software catalog, which is a single source of truth that is always up to date with all of the relevant information about your software ecosystem, all of your different services, cloud resources, teams, deployments, incidents, and more. The self-service hub, which is basically a one-stop shop for all of the routine operational work that engineers need to do, starting with creating new services, resources, and environments and more, all the way to managing their life cycles. And then the standards or the scorecards that allow you to define quality and operational standards. So for example, operational maturity, production readiness, code quality and security, cloud costs, and the broader FinOps for your entire organization. And then it gives you the tools to automatically review and ensure that those standards are met. All right, and with this, without further ado, let's go straight into the actual product. Today, I'll be walking you through the main building blocks with three different use cases. One, onboarding a new engineer with all the information in one place, making it much easier for that engineer to be fully enabled and reducing the time to code for the developer. The second one being with the self-service hub, how to streamline the process of creating a new service, going from taking like 3 weeks with all of the different shared concerns like setting up CI/CD, observability, creating the boilerplate code, setting up networking, and more, to a couple of minutes, as I'm going to show you, while following all of the different standards of the organization, improving quality and reliability. And the third, using the scorecards to promote and keep track of the adoption of engineering standards. All right, so first, let's show you the software catalog. As you can see all of the services of the organization, all of the different cloud resources, Kubernetes resources, the different domains, different teams, and more. A single system of records, unifying all of the relevant information about each of these different assets or teams in a single place and making sure that it is always up to date, making it much easier to discover information. So let's imagine that you're an engineer being onboarded into the analytics team. You get into the analytics team, and all of the information that you need to build features and services for this team is in here. So to collaborate, you can see who the team members of the team are, the different communication channels so that you can subscribe to them and always be up to date on the latest information, the domain that you're going to be supporting, the services that the team owns, who is going to be on call in case you're building something or iterating over something and you break something, you know who to call, all of the relevant documentation, wiki guides, and more. And then you can drill down into the services that you own. So basically here in the service homepage for the recommendation service, you can find everything that you need to quickly contribute to this service. All of the relevant documentation and runbooks and architecture designs, the README, where you can basically very easily understand what the service does, and you can get up to speed quickly and have it up running locally so that you can start contributing to it. And all of the relevant information like API specs, for the service in production so that you can contribute to it or use existing APIs of other services, all of the relevant information around incident management, production health to monitor your service in production, all of the relevant monitoring and observability dashboards, alerts, and more. CI/CD for the service so that you can see where the service is running, in which environments, what are the different instances of the service, the latest deployments, and all of the different actions to iterate upon this service, to manage the service, like deploying a new image that you just built by doing a checkout of your branch with a new feature, a new version of your service that you just created, doing a rollback, toggling a feature flag, and many more. Like you can see the infrastructure that the service is using. You can have the actions to manage its life cycle, basically reducing the time that it would take to start to contribute to the service and to the product features that you are responsible for within your domain. Now let's say that you're fully onboarded, you got up to speed much quicker because all of the information was easy to find and all of the standards and the actions that you need to build software throughout the full software delivery life cycle are centralized. The next thing that you're going to do is to create a new service. So you go to the self-service hub where all of the different actions that you can do to create and iterate with the existing software are in here, and you're going to scaffold a new service. You're going to choose your team out of the teams that are available in the software catalog, since this is fully integrated with your software catalog. You're going to name this service, it's Fast API Order Service, for example, and you're going to choose out of the existing boilerplates or templates for you. In this case, it's going to be a Fast API boilerplate, and you're going to submit it for approval so that whoever has the permissions to approve this process can review the action and decide to approve it or not. So for example, in here, they can see who ran the action, what were the inputs. This is the title of the action, this is who ran the action, when it was created, and then you can see what the action is going to do. So in this case, this action is automating all of the different steps to create a new service. Let me show you, like creating the repo, scaffolding the boilerplate code, setting up the default branch and enabling branch protection, setting up the webhooks of the repo, setting up the image registry, setting up and provisioning the Kubernetes cluster and all of the relevant infrastructure like databases, Redis cache, S3 buckets, so on and so forth, setting up the SonarQube project, observability, the CI/CD pipeline, networking and load balancing, and deploying the service. Something that would take days, if not weeks, to set up, and the developer would be blocked and waiting for the operations team to take care of all of this for them. And here, it is approved, and you can quickly see this getting fully automated. So as you can see, then it starts running very quickly, and the actions are automated, so they get taken care of in seconds. You've got the logs to troubleshoot if anything goes wrong and to understand what's happening live. And just for the sake of this demo, I don't want to wait for it to finish running. I can just go to the historical runs, and there's this running action, but I'm going to go to the historical runs, see one that has already completed. And as you can see the execution of all of the different steps, and you can see the outputs of the service that was created, along with the different resources that were provisioned, the Grafana dashboards, Datadog SLOs, and more. And then you can actually see the service that was created and these resources in the software catalog. So the monitoring dashboards that were created are listed in here, easily accessible. The key information about the service is populated, like it's a backend service, it's owned by the analytics team. Here is the repo that was created, the coding language. There's still no documentation for this service, but you could create it. There's no README, and you just add it in here. But there are API specs, they're already added in here. based on the boilerplate code that was created for this service. And then you can see the infrastructure of this service. And as you can see, it was deployed in this Kubernetes cluster. It's running on these pods, and it is using this EKS cluster and this S3 bucket. You've got all of the actions that you need to provision, for example, a new database, a new EC2 instance or an S3 bucket, and to do data operations, to manage, for example, to do a rollback to a previous deployment. Let's say that in this case, a few days after you've created the service, there's an issue. You see that, for example, the number of replicas is not matching the desired number of replicas. You can do a rollback of the deployment, and you can very easily choose the previous deployment. Once again, since it's integrated deeply with the software catalog, all of the previous deployments also show up in here. So it's a full unified experience to create and manage the lifecycle of services, resources, and environments. Then, for the final use case, let's say that you're an engineering leader and you're managing, for example, the analytics team. You can actually go and check the productivity metrics of the engineering team. So, for example, you can see the number of deployments to prod and to development to see their productivity and see how fast they're shipping and how often they're shipping, how the lead time for change, both for production and development. So basically, the average time between opening a pull request and it being available in production, to see how efficient the team is in pushing new changes, the latest number of incidents, the mean time to resolve incidents, the change failure rate, so often new deployments end up failing, and how fast you recover from failed deployments, and more, because all of this is customizable and you can extend these insights. But also, you can actually define certain standards. So in this case, for teams, it's like you can follow the DORA metric benchmarks and see if the team is complying with these benchmarks. In this case, it is not, because it is not meeting these requirements for bronze. But not only can you track DORA metrics, but you can also track other types of engineering standards. Standards like cloud cost and efficiency, code quality and security, operational maturity, production readiness. And since Relay is deeply integrated with your engineering stack, you can actually define the requirements, and Relay validates in the different tools like GitHub, PagerDuty, so Git providers, incident management, observability tools, code quality, and more. And it automatically assesses the compliance of each team and service against the requirements that you defined. And then it creates a leaderboard so you can see for each of the different services, for example, what is the rank. In this case, since this service is not meeting these two bronze requirements, it is not even meeting a rank of bronze. And you can easily see the up-to-date value in real time for each of the different requirements. So for example, in here, it needs at least one deployment in the past month, but there's zero. And you can do this for all of the different teams so that you can understand what teams need to improve. And then the teams know exactly what they need to improve to meet the standards that have been defined. So for example, this team is gold in cloud cost and efficiency, code quality and operational maturity, but it's not meeting production readiness standards. So the team can very easily and quickly understand what are the best practices that I should be following and what am I missing. And in this case, the pull requests do not require at least one peer review in the repo of this service, and there wasn't at least one deployment this month. And the code coverage is not above 75%. So to be able to be silver, you know exactly what are the requirements that you need to meet. And for gold, you need to have an alerting tool configured, no open vulnerabilities in Snyk, and once again, it makes it super easy for the teams to gamify the adoption of these standards, because basically they get to different levels and they know exactly what they need to do. It's a charted path for them, and for engineering leaders, it's very easy to create an accountability loop, because you always have an up-to-date state of how things are doing. With this, I wrap this up. Naturally, there's a lot more to the product. Happy to do a deep dive in any of the different capabilities or any of the different use cases. But thanks for bearing with me. Hope you enjoy this and you are as excited as I am about this. And have a great day. Cheers.